Hello students. Today we will start chapter 7 Database Concepts. Students, after learning about importance of data in the chapter number 1, we need to explore the methods to store and manage data electronically. Let us take an example of a school that maintains data about its students along with their attendance record and guardians' details. As you all know, the class teacher marks daily attendance of the students in the attendance register. The teacher records P for present or A for absent against each student's roll number on each working day. If class strength is 50 and total working days in a month are 26, the teacher needs to record 50 multiplied by 26 records manually in the register every month. As the volume of data increases, manual data entry becomes tedious. The limitations of manual record keeping are entry of student details like roll number and name in the new attendance register when the student is promoted to the next class. Writing student details on each month's attendance page where inconsistency may happen due to incorrectly written names, skipped student records. Loss of data in case attendance register is lost or damaged. Erroneous calculation while consolidating attendance record manually. Students, finding information from a huge volume of papers or deleting and modifying an entry is a difficult task in pen and paper based approach. To overcome the hassles faced in manual record keeping, it is desirable to store attendance record and students record on separate data files on a computerized system so that teachers can simply copy the students' details to the new attendance file from the old attendance file when students are promoted to the next class. Find any data about student. Add more details to existing data whenever a new student joins the school. Modify stored data like details of student whenever required. Remove or delete data whenever a student leaves the school. This data handling is performed by arranging data in the form of tables and databases. Now let me introduce you with file system. A file can be understood as a container to store data in a computer. Files can be stored on the storage device of a computer system. Contents of a file can be text, computer program codes, comma, separated values, and so on. Files stored on a computer can be accessed directly and searched for desired data, but to access data of a file through software. For example, to display monthly attendance report on school website, one has to write computer programs to access data from files. Now there are the limitations of a file system. Students, file system becomes difficult to handle when number of files increases and volume of data also grows. There are some limitations of a file system. They are difficulty in access. It means files themselves do not provide any mechanism to retrieve data. Data maintained in a file system are accessed through application programs. While writing such programs the developer may not anticipate all the possible ways in which data may be accessed. So, sometimes it is difficult to access data in the required format and no one has to write application program to access data. Data redundancy. Data redundancy means duplication of data. Duplicate data is stored at different locations when violates the integrity of the database and causes wastage of storage space. Data inconsistency. Data inconsistency occurs when same data maintained in different places do not match. Data dependence. Data are stored in a specific format or structure in a file. If the structure or format itself is changed, all the existing application programs accessing that file also needs to be changed. Otherwise, the programs may not work correctly. This is data dependency. Hence, updating the structure of a data file requires modification in all the application programs accessing that file. Limitations faced in file system can be overcome by storing the data in a database where data are logically related. Now let me introduce you with database. A database is defined as an organized collection of data about any entity or thing. It is a shared collection of related data used to support the activities and decision making of a particular organization. It also allows the user to enter, access, and analyze their data quickly and easily. Databases are widely used in various fields, like some examples are banking. Database is used to store customers' information, account details, loan details, transaction details in banks. Corporate loans. Database is used to store Kisan credit card data, farmers' personal data, land area and cultivation data, loan history, repayment data. Inventory management. In inventory management, database is used to store product details, customer information, order details, delivery data. Organization resource management. In organization resource management, database is used to store employee records, salary details, department information, branch locations. In online shopping, database is used to store items description, user login details, user's preference details. Now, let me introduce you with database management system. A database management system or a database system is a software that can be used to create and manage databases. A database system has a set of programs through which users or other programs can access, modify, and retrieve the stored data. Some examples of open source and commercial database management system includes MySQL, Oracle, SQL Server, Microsoft Access. Now, in order to efficiently manage data using a database management system, let us understand certain key terms. These key terms are database schema. Students, database schema is the design of a database. It is the skeleton of the database that represents the structure like table names and their fields and columns, the data type of data each column can hold, constraints on the data to be stored if any, and the relationships among the tables. Data constraints. Sometimes we put certain restrictions or limitations on the type of data that can be inserted in one or more columns of a table. This is done by specifying one or more constraints on that column while creating the tables. Metadata or data dictionary. The database schema, along with various constraints on the data, is stored by database management system in a database catalog or dictionary. This is called metadata. Database instance. When we define database structure or schema, state of database is empty. That means no data entry is there. After loading data, the state or snapshot of the database at any given time is the database instance. Query. A query is a request to a database for obtaining information in a desired way. Query can be made to get data from one table or from a combination of tables. Data engine. Database engine is the underlying component or set of programs used by a database management system to create database and handle various queries of data retrieval and manipulation. Now students, let me introduce you with relational data model. Students, different types of database management system are available and their classification is done based on the underlying data model. A data model describes the structure of the database, including how data are defined and represented, relationships among data, and the constraints. The most commonly used data model is relational data model. In relational data model, tables are called relations that store data for different columns. Each table can have multiple columns where each column name should be unique. Now let me introduce you with the commonly used terminologies in relational data model. Attribute. Now what is attribute? In relational table, an attribute is a set of values or a particular type. The term attribute is also used to represent a column. A table consists of several records and each record can be broken into smaller entities known as fields or attributes or columns. A set of attributes defines the characteristics or properties of an entity. For example, roll number, name, address. Tuple. Each row of a data in a relation is called a tuple. It is also called a row or a record. A single entry in a table is called a record or row. A record in a table represents a set of related data. Domain. It defines the kind of data represented by the attribute. It is the set of all possible values that an attribute may contain. For example, in student relation, the attribute roll number takes integer values and hence its domain is a set of integer values. Degree. The number of columns or attributes in a table or relation is called the degree of the relation. Cardinality. The number of records or tuples in a table or relation is called cardinality of the relation. Now let me introduce you with keys in a relational database. There are various keys used in a relational database. These keys are candidate key. A relation can have one or more attributes that takes unique values. Any of these attributes can be used to uniquely identify the tuples in the relation. Such attributes are called candidate keys, as each of them are candidates for the primary key. Now, primary key. Out of one or more candidate keys, the attribute chosen by the database designer to uniquely identify the tuples in a relation is called the primary key of that relation. The remaining attributes in the list of candidate keys are called the alternate keys. Composite primary key. If no single attribute in a relation is able to uniquely distinguish the tuples, then more than one attribute are taken together as primary key. Such primary key consisting of more than one attribute is called composite primary key. Foreign key. A foreign key is used to represent the relationship between two tables. A foreign key is an attribute whose value is derived from the primary key of another table. This means that any attribute of a relation referencing which is used to refer contents from another referenced relation becomes foreign key if it refers to the primary key of referenced relation.